Welcome to the next lesson in this chapter, where we are going to start implementing synchronous communication between our modules. You should go ahead and download the updated version of the source code from under this video, because I have added a few items to the carts feature folder inside of our ticketing module, and let me show you what they are. I added a cart class that's going to contain the customer identifier representing our current customer. Then we're going to have a list of items that are present in the cart, a helper method to create a default empty cart. The cart item is going to represent what is the ticket that we have added to the cart, and if you recall, the ticket type is an entity in the events module. We will also have the quantity for how many tickets a customer has added, the ticket price, as well as the currency that are all available on the ticket type entity. And then we also have the cart service, which is an interesting one because I'm using Redis to store the customer's cart. The cart service is injecting the cache service interface, which we implemented in the cross-cutting concerns chapter, and we are using it to store the current customer's cart in the Redis distributed cache. So we have a getAsync method to fetch the cart for the specified customer identifier. We're going to create a cache key and then see if this value is present in the cache. We also have a helper method to clear the customer's cache, and then there's the method that we will be implementing for adding an item to the customer's cart. It's going to need a customer identifier, a cart item instance, then it's going to check if there is an existing item of this ticket type in the cart, and if there is not, it's going to add a new one. Otherwise, it's going to update the cart item quantity. And lastly, we need to persist the new state of the cart into Redis. There's also a method to remove an item from the cart, and this will be used in the respective use case. And then the cache key is just carts, and we append the customer identifier. So let's go ahead and implement the use case, or at least start to implement it, and then we'll see where we get stuck. So let's call this the add item to cart, and I'm going to add a respective command inside. So let's call this the add item to cart command. We're going to make this a public sealed record. It's going to implement the iCommand interface. And what do we need from the arguments? Well, we need a GUID representing the customer identifier. We need another one for the ticket type identifier. And then we need a decimal value representing the quantity, which is actually how many of this ticket type do we want to add to the cart. Let's also implement a simple validator for this command. So this is going to be the add item to cart validator. It's going to implement the abstract validator base class. And then in the constructor, I'm just going to have a few simple rules. The customer ID can't be empty, as well as the ticket type ID. And then I will have a custom rule for my quantity. I will say that the quantity must be greater than decimal 0. And finally, let's add our command handler. And this is where things will start to get interesting. So this is the add item to cart command handler. It's going to implement the iCommand handler interface. So let's add the handle method. And then we're going to depend on the cart service as our dependency. So let's add that. We also need to register this with dependency injection. So let's do that from the ticketing module. So inside of the add infrastructure method, going to say services add singleton, because this is depending on the cache service, which is already a singleton, and let's register the cart service as a singleton service with dependency injection. Now back to our command handler. Inside of the handle method, we need to do three things. First of all, we need to get the customer based on the identifier. Then we need to get the ticket type information, and finally, we need to add the item to cart. So these are the three steps that we have to implement, but the problem is we don't have the customer's information inside of this module, and we also don't have the ticket type information inside of the ticketing module. So how are we going to solve this problem? This is where we need to start communicating with the other modules in our system, and let's start with the customer. The customer identifier in the ticketing module will be the same value as the user identifier in the users module. So because we are implementing synchronous communication, I'm going to introduce another project in the users module that is going to contain the public API of this module. So let's add a new project. It's going to be a class library, and let's call it Evently Modules Users, and let's say public API. I'm going to create this as a .NET 8 project, and let's repurpose this class into iUsers API. So this is actually going to become an interface, And on this interface, what are the methods that are going to be callable from the other modules in my system? So let's expose one method. It's going to be asynchronous, and it's going to return some sort of user response. Now this type I don't have yet, but we're going to add it. And let's call this the getAsync method, accepting a user identifier. We can also pass in an optional cancellation token, and then we need to define the user response. Now I'm going to reuse a type that I already have in my getUser use case. So this is the user response. So let's create another contract with the same name and the same values. If I didn't make a typo in the user's API, this would have worked, but now my method is referencing the correct contract. And what's the point of this? Now I can go back to the ticketing module, add a project reference to the public API of the users module. So let's go ahead and do that. And in the add item to cart handler, we're going to add a dependency on the users module API. So let's inject the users API. And now I can start to implement the first step. So the customer is going to be users API getAsync, and we're going to pass in the customer identifier. I'm calling this a customer because this is the naming convention that we are using in this module, and I should actually make this a nullable response. So let's update the users API to also return a nullable value. In case that this value really is null, let's return a failure from this handle method. So I will say if customer is null, return result failure, and I have some customer errors defined in my domain project, and I can specify a customer errors not found error. As it stands right now, our code will not work because we don't have an implementation for the iUsers API interface. So let's go ahead and add that in the users module. I'm going to implement this in the infrastructure project. So let's add a new folder representing the public API. And inside of it, I'm going to add a new class, which is going to be the users API implementation. Let's make this an internal class, and let's implement the iUsers API interface. Now we don't have a reference to this project, but I'm going to add it. And let's add the missing members, which is the getAsync method. Now I will make this asynchronous, and we could implement this in many different ways. For example, I could inject the database context and use it to query the database directly. I could even use the user repository that I have here, but this would be a bit less performant. And one more thing we can do is just leverage the existing query that we already have inside of our use cases. So I'm going to inject a nice sender from Mediator, and let's send a new get user query. So let me create a new get user query. We already have the user identifier, and let's pass in the cancellation token. This is going to return a respective user response, which is defined in the application project, which is why you can see the full namespace declaration here. Now, if this is a failure result, we're just going to return null from this method. Otherwise, let's return a new user response, and we're going to map this from our result value. So I'm just returning the respective values for the first name, last name, email, and the user identifier. I also need to register this with dependency injection. So let me head over into the users module, and I'm going to add this as a scoped service. So let's say add scoped iUsers API, and then I'm going to declare the users API implementation. And this completes the implementation of the public API of the users module. So our public API is just a simple interface exposing a method that we can call on the users module, and it's also defining a contract for what is going to return when you call this method. Let me move the user response into its own file, and let's go back to the add item to cart use case. I'm going to close down the rest of these files, and then the next thing that we are missing is the ticket type. So let's follow the same approach. I will close down the users module, and let's head over into the events module. Let's add a new project here. It's going to be a class library, and I'm going to call it Evently Modules Events Public API. This is going to be a .NET 8 project, and inside of it, we're going to define the iEvents API. Let's make this an interface, and this is going to need a method to return a ticket type response. So let's add a ticket type response. I already have a record like this, so let's reuse this contract, and I'm going to define it here, and let's add a method called getTicketTypeAsync. It's going to have an argument accepting a ticket type identifier and a cancellation token. The next thing we need to do is implement this interface in our infrastructure project in the events module. So let's add a public API folder. Inside of it, I'm going to define a new class is going to be called Events API. This class will be internal and sealed to the Events module, and we will be implementing the iEvents API interface. For this, we need to add a respective project reference, and then I can use the same approach as before